Today we're going to start with types of mixture. Walaikum Assalam. Today we're going to start with types of mixture. हमारे पास actual life में pure substances सारा वक्त नहीं होते. हम mixtures बहुत ज़्यादा use करते हैं. For example, जो पानी हम पीते हैं, वो भी एक mixture है. Mineral water is a mixture of water and salts. जो हवा हम सांस लेने के लिए इस्तेमाल कर रहे हैं, the air we breathe, is actually not a single gas. It's a mixture of many gases. You're familiar with that. Composition of air is a part of previous classes. For example, you know, air is mainly composed of nitrogen gas. Then on second number, we have the oxygen gas with the second main composition portion. And there are other gases as well. So we're going to define a few important definitions over here. Let's start with the definition of mixture. Each mixture must be made from at least two parts. There may be more parts, more than 2, 3, 4, 5, maybe even more than that, which may be solid, liquid, or gas. So that's the basic definition of mixture. So mixtures can be made in a very different number of ways, or in which all three states or any number of states can be combined. In some, the states are completely mixed to become one single state or phase. You cannot see the join. Technically, the term solution is used for that type of mixture when you cannot see the join, when you cannot differentiate between them. All right. So that's how we define solution, but that's not a very good definition. Let's move on to make sure that the concepts are clear and we get to some better definitions. Solid salt dissolves in water, liquid water to produce a liquid mixture, a salt solution that we call it. In general terms, the solid that dissolves in the liquid is called the solute, and the liquid in which the solid dissolves is called the solvent. Every bold word over here is actually a definition completing that line. In other types of mixtures, the states remain separate. One phase is broken up into small particles, droplets, bubbles within the main phase. Perhaps the most obvious example of this type of mixture is actually a suspension of fine particles of solid in a liquid, such as we often get after a precipitation reaction. A diagram is shown over here, which gives you a very good idea that how solid salt is commonly dissolved into a liquid solvent. The salt particles are represented with green color. However, the solvent particles are represented with blue color. Consider blue as water and consider green as the simple table salt we eat every day. So that's how you get a solution. And in solution, solute particles cannot be seen. The overall phase or the overall state of the system is liquid. All right. So defining the most basic of things, for example, mixture, for example, solution, for example, solute, for example, solvent, and suspension are quite easy stuff. Suspension in this case is quite a definition which is different from the others. Sometimes solute, solvent, solution, mixture are the definitions we have studied in previous classes, and suspension is something we tend to forget. However, suspensions are solutions which we get in our daily life. For example, all our cough syrups are actually suspension that we use. Also, in sometimes for drinking purposes, we use some suspension mixtures in our daily life, which include sometimes the suspensions of specific types of seeds or fruit particles in water or in sweet syrups, and we call them as our drinks. There are many examples to it. I hope you are clear about that. Now, solutions can be further defined or further bifurcated into many parts. We'll discuss them some before this main heading of 2.2, separating and purifying substances, and some after that. We're going to define solutions on many different bases. Now, in previous classes, the definitions were very easy. something can be bifurcated into 2 to 3 types, and that's about it. But in IGCSE, the definitions get a little bit difficult because they are then divided or bifurcated on the basis system. On one basis, we might have 2 to 3 types, then we go on to another basis. On another basis, we might have the same number of types again, and then the third basis, and the fourth one. So there are many different types over here. That's exactly the same thing that we are going to do in case of solutions. For example, there are various ways in which substances are in different states can be combined. Perhaps the important idea here is that of one substance dissolving in another, the idea of the solution. We most often think of solution as being made of solid dissolved in a liquid. Two-thirds of Earth's surface is covered by a solution of various salts and water that are our oceans actually. The salts are totally dispersed in water and cannot be seen. However, other substances are not normally solid, dissolved in seawater. For example, the dissolved gases, oxygen and carbon dioxide, for example, are most important for life to exist in the oceans. So gases are also dissolved into water. That's another example for solution. Less obvious perhaps, but quite common are solutions of one liquid in another. For example, alcohol mixes or dissolves completely in water. Different types of alcohol such as beer, wine, whiskey do not separate into layers of alcohol and water. Even when the alcohol content is quite high, they do not make any separate layers. Okay? Alcohol and water are completely miscible. We use miscible word here. You can think that we use the word miscible when one liquid is mixed into another. That's correct. Yes, we use the word solution when a solid or a gas is dissolved into liquid, but when a liquid is dissolved into a liquid, we use the word miscible solution. All right. The word miscibility represents that. Then they can make a solution. So moving on to other examples, alloys are simple mixtures of metals. Though we do not usually call them solutions, they are made by mixing the metals, liquid metals together, dissolving one metal into the other before solidifying the alloy. What do? We change the temperature. We go to such a high temperature that both the metals are actually converted from solid state to liquid state. Then those liquid metals are combined together, mixed together, stirred by simple stirring. And when one metal is dissolved into the other, we once again reduce the temperature. By reducing the temperature, what happens is that we solidify those metals in not just this time into separate metals, but into a mixture, and we call that mixture an alloy. For example, copper can be mixed with iron, or we can also mix manganese or nickel or other metals with iron. Hence, we make stainless steel. I hope you're familiar with the word steel. We have used it many times. Many of the things around us are made out of steel. For example, one of the most important things around us is the cutlery. The spoons and the forks we use every day are made out of stainless steel, and that steel is actually an alloy in which iron is mixed with different other metals such as chromium, such as nickel. All right. So that's how we come up with examples of alloys, and alloys are actually mixtures. We don't exactly call them solutions, but they are a type of solutions. This is just a general idea. We are going to actually bifurcate solutions into proper definitions after topic 2.2. All right, at the end of actually topic 2.2. Let's move on to our main topic. We just required a few words to go with and few concepts to clear before we moved on to topic 2.2. After topic 2.2, we'll come back to this solutions definition. Let me give you a brief idea. After we're done with many different types of separation techniques, we'll come back to different kinds of a closer look at solutions. We'll once again come back to solutions, the solutions of solids and liquids, the solutions of gases and liquids, their solubilities, we'll discuss many different types of solutions over here. Okay? So a brief idea is required as a prerequisite for topic 2.2. However, at the end of topic 2.2, we'll give them a very good description and we'll make sure that we go with all possible bifurcations and their definitions separately. So for now, from the solutions part, you don't have a definition to memorize. It was just for information so that we can go through with this 2.2 portion easily. However, the definitions such as suspension, solvent, solute, and the basic definitions such as solution and mixture, these you can memorize. For this purpose, I don't exactly ask you to memorize these lines from the book. That might not be good because this is much of a description than an exact definition. So what I ask my students is that at the end of the book, let's go to the end of the book. Just give me a second. At the end of the book, we have this glossary, right? The glossary is actually a collection of all the possible definitions that are used in this book. The glossary actually starts from, let's see which page number it starts from. The glossary actually starts from page number 336 for this book. All right. So what we are going to go with is that we are going to go to the possible definitions that we have here in our glossary. For example, let's define mixture from this portion. Instead of defining mixture from the actual page we were at, define mixture from this portion. Then let's come to other definitions. Let's see, what do we have here? We have the term solute, solution, solvent, these definitions, and finally suspension. So all five of these definitions are supposed to be done from here rather than the original page of the book. Why? Because over there, the definition is sometimes mixed with description. However, in paper, you're going to quote the actual definition when asked, and you're not going to write any descriptions. Okay? Because in paper, the marks are for definition, not for description. I hope that makes it clear. So let's go back to the page we were at. And we're going to start 2.2 with separating and purifying substances. Now this 2.2 portion is very important. It's actually the most important portion of chapter number 2. And this is important for your theory paper, as well as for your MCQ paper, as well as for your ATP or alternative to practical paper, because from chapter number 2, this is the most important portion that is also a part of ATP paper, because separating and purifying substances will be consisting of many different experiments to come, and those experiments are a part of practicals. Okay? I will clarify which parts you're going to do for what purposes when we are going through those parts exactly. Now, to make sense of the material world around us, we need methods. We need different methods for physically separating the many and varied mixtures that we come through. Being able to purify and identify many substances present in these mixtures not only satisfies our curiosity, but it is crucial to our well-being and our health. There is a range of physical techniques available to make the necessary separations of mixtures and of solutions. For example, just let me walk through that by giving a daily life example. Fruits are a very good part of our life. Now, if I have 10 different students in the class, I must have 10 different opinions about fruits. Maybe one of you like apples the most, and some other student like mangoes, some other one like bananas at the top of their list. So there are different likenesses for different fruits in our life. Not just that, we usually are very used to using the fruit mixtures. We call them fruit chart, a very common recipe used in our homes. What do? we cut up small pieces of fruits and we mix up our favorite fruits. But sometimes our mothers tend to also mix up some fruit in that fruit chart which we don't like. Let's consider an example over here. Let's consider an example for a couple of exact participants over here. Let's say Abu Bakr is going to eat a fruit chart that his mother made for him. And Abu Bakr is a very good fan of, let's say, mangoes, and he also like apples and bananas, but he doesn't like the pomegranate seeds. But his mother came up with all four uh, fruits together as a part of fruit chart. Now, what Abu Bakr is going to do is that he's going to actually bifurcate them into pieces for himself. He's going to carefully, with his spoon, pick up the pieces of mangoes and apples and bananas, but he's going to carefully leave out the pomegranate portions and seeds out of them, as he doesn't like it. Just consider it as an example. So sometimes the separations are easy. Sometimes the separations are difficult. For example, if there are smaller pieces of fruit, for example, if let's say in the same fruit chart, Abu Bakr's mother come up with an idea that we need a little bit of orange juice, and she drips that orange juice all over the fruit chart. Now, Abu Bakr won't be able to get rid of that juice because that juice is a liquid and that would go through all over the fruit chart. Separating some pieces of banana, separating some pieces of mangoes or some pieces of apples is easy. Even separating the smaller seeds of pomegranates is easy as well. But separating orange juice out of that whole fruit chart, that might not be easy. So separation has many different procedures. Sometimes those procedures are easy, sometimes those procedures are tedious and difficult. So considering this simple example of fruit chart at home, we can come up with different kinds of ideas about separation. Sometimes the separation can be as easy as hand picking, picking some things from hand or with the help of a spoon or with the help of a spatula in lab, but sometimes it comes difficult. Now, this all depends, let's come back to our original lines. They all depends in some way on a difference in physical properties or appearances of the substances in the mixture. Now, the most useful separation method for a particular mixture depends upon two things. What is the type of mixture that we are dealing with, and which substance in the mixture we are most interested in. And the second point is quite common when it comes to fruit chart. If you're interested in mangoes, you might pick out the mangoes in the fruit chart first. If you're interested in apples, you might go for apple pieces first. And if there is a fan of bananas, then of course he's going to go bananas after the banana pieces, right? So that's important, the type of mixture that we are dealing with, and of course the substance in the mixture that we are most interested in. Now, we're going to go with many different methods. This topic is approximately going to discuss 10 different methods, and we'll discuss one after another and make sure during these methods you are carefully understanding and picking up the concept. But if you confuse one method with the other, I want you to interrupt me right there and then so that I can answer your question and I can make sure that you understand it. All right. So Googling any method or going for a YouTube video for any method is very good because a a YouTube video would clear out a lot of concepts. Okay? In fact, we're going to consider some of the videos in our lessons as well. Okay? Starting from soluble, separating insoluble solids. Now, I hope you're familiar with the word insoluble. The solids that do not dissolve in liquids, those solids are considered as insoluble solids. For example, sand cannot be dissolved into water. Sand is heavy and simply settle down at the bottom of the glass or the beaker in which we are trying to dissolve it in water. See? So we call it insoluble, and separating these insoluble solids from liquids, that's our starting point for separating techniques. Let's start with that. In some ways, these are the easiest mixtures to separate. Quite often, just leaving a suspension of a solid in a liquid to stand achieves this separation. ठीक है? Especially if the particles of solid are large enough, they can be easily separated. For example, if a stone falls into a glass of beaker, taking out that stone would be easy for you. Sometimes there are smaller pieces of soil or sand in water which is insoluble, but even those can be easily separated. How? Once the solid has settled to the bottom of the beaker or to the bottom of the vessel we are dealing with, the liquid can be carefully poured off from the top. This process is called decanting. Decanting is the first process that we are going to do over here. So decanting is actually quite easy. The insoluble solid settles at the bottom of the vessel and the liquid which is on top can be carefully poured off. Decanting actually itself means careful pouring. Class, are you clear about careful pouring or should we go ahead and watch a video about it? If you're clear, good enough. If even a single person is not clear, we can always go for a YouTube video right here. What do you say? Okay, Zoya, that's good. I like your honesty. Zoya says that a video would be a much better idea. So let me go into this. Let me stop sharing of this book and let's just get to a YouTube video. Just give me a second to do that. All right. So we are going to consider decanting for that purpose. A simple process, pouring a liquid carefully out of a container when the solid is settling down at the bottom. She's doing that for careful pouring. Although the solid at the bottom moves, but you are going to be extremely careful to just pour off the liquid. Okay, this part needs a little bit of explanation. Sometimes the pieces of solid are so big, as you can see in front of yourself in this video, that they do not move easily. Sometimes the pieces of solid are somewhat less bigger than these. They're smaller and they start moving with the liquid. Hence, decanting is though a very easy technique, but here comes the technical part. If during the careful pouring of the liquid, any parts of the solid comes with the liquid, your process failed. You need to redo the whole thing, right? So decanting, we say, is not much of an efficient process. This process actually um, is not an efficient process because sometimes the the solid pieces tends to come with the liquid. If that happens, you haven't done it correctly, you need to redo the whole experiment. One. Two, this process is also not efficient because sometimes, in order to make sure that the solid does not come with the liquid, some of the liquid remains behind in the original beaker. To be a little precautious, we do not pour or we do not try to pour that liquid out of the system. So we do not get all of the liquid. And if in some kind of separation technique, we do not get all of the substance that we were interested in, it is not considered a good technique. It might be an easy technique, but it is not a completely efficient technique, which gives us the idea that some techniques are very efficient, some techniques are more efficient than the other, some techniques are good because they can get us the substance in the complete proportion that we were interested in, but in some cases we might not be able to separate or purify all of the substance that we are interested in. Hence, the loss of the substance that we are interested in is also possible. All right. I hope you get the idea. Any questions so far about decanting? Because this video is almost complete. All right. So let me stop sharing over here and let's go back to our book. So this is decanting. Let's move on to next portion. And decanting is used to separate insoluble solids from liquids. Now, you would see a table 2.3 on the top of this page number 28. This table is important for us. Let's go through the table. One of the processes from this table is something that we are already done with, but there are approximately 8 to 9 more processes that we still need to go with. Let's go through the table. You would see there that there are two bifurcations in the table. One column is of mixtures. So for different types of mixtures or for different types of solutions, we have different methods of separation. Starting from solid plus solid mixtures, which are actually powdered mixtures, we use some differences in properties. Sometimes the difference is of density, sometimes solubility, sometimes sublimation, sometimes magnetism. We're going to define all of that in a lot of detail a little later. Let's continue with this table. The next mixture would be suspension of a solid in a liquid that can be separated by filtration and centrifugation. You might be familiar with filtration, but we are going to define all of that once again in a lot more detail than your previous classes. Moving on, liquid plus liquid, which is immiscible, means one liquid was not able to dissolve in the other, can also be used over here. We can use a separating funnel for that purpose, or decantation or decanting. Decantation or decanting means the same thing, it's the name of the same process. So that can also be used. This process that we use for the separation of an insoluble solid in a liquid, that can also be used for an insoluble liquid in a liquid. But as I told you before, for liquid-liquid mixtures, if they can dissolve, we use the word immiscible. And here, as the book suggests, if those liquids cannot dissolve into one another, the word immiscible is used. For example, petrol and water cannot be mixed into one another. For example, oil and water cannot be mixed into one another. And they form two separate layers. Even if we try, then decantation can also be a separation technique for those kinds of liquids. We'll discuss that a little later. Coming to the next point, we have a solution of solid in liquid. Now, in order to obtain solid, now that point is very important. We might be interested in the solid to obtain, or we might be interested in the liquid. In order to obtain the solid, we use evaporation or crystallization procedures. And in order to obtain liquid, we might use distillation procedures. You might be familiar with the names of these processes or somewhat definitions. Sometimes in previous classes, we also studied their techniques and methods in detail, but here the details would be much more in the previous classes. Continuing with the next portion, two or more liquids, when they are mixed together and they are miscible in one another, by that I mean they can be easily dissolved into one another. For example, soda can be mixed into water, or soda can be mixed into milk. Soda milk is a common thing that we use in our homes during the summer season, especially during the Ramzan times. All right. And solution of two or more solids in a liquid, that is also possible. For example, if we can dissolve a salt in water, we can dissolve some amount of sugar in the same water. And nowadays, in summer season, lemonades are also common. So for lemonades, we dissolve a little bit of salt and a little bit of sugar in the same amount of water. So that's actually a solution of two solids in a liquid. So for this purpose, the name of the method is chromatography, and we're going to go with this method in this chapter in this portion as well. All right. This table and the memorization of this table is very important. Make sure you mark the table and make sure after going through all of these processes, you're going to memorize the table. Don't go for cramming right away because many of these names are over here. You're not familiar with them. So let's study them first. And when you're familiar with these names and these processes, then try to memorize the whole table. All right. So moving on. Continuing, our next process, a more generally useful method for separating solids that are insoluble from liquids, is filtration. Now, here the insoluble material is collected as residue. That's how we define the word residue on a filter paper. Filtration is useful because both phases can be obtained in one process. Now, this is the reason why we consider this process generally useful. Why? Because one thing is not wasted and the other is received or separated. Actually, both phases can be obtained in just one process. The insoluble solid material by the name of residue is collected on filter paper. The liquid phase is collected by the name of filtrate separately in a beaker. Let's go through the diagram over here. Take a look at this diagram. We have a proper stand. We call the stand as support. We call the stand as retort stand actually. Okay. Let me write the word over here so that you can also write it over in your books. This is actually a retort stand. All right. The name of the apparatus is important, so you're also going to memorize that. I hope you have written it. They are simply calling it a support, but actually the whole thing is a retort stand. We are using a filter paper and we are using the filter paper inside of a filter funnel. The solid stops over the filter paper in the form of residue. We call that residue. We call the solid the residue, not the filter paper or the filter funnel. Now, the water or the liquid moves through the system drop by drop, is collected at the bottom in a beaker, and this liquid, which filters through, is something that we call the filtrate. Whichever liquid is obtained over here will be known as filtrate. Whichever solid would be obtained over here would be known as residue. So that's how the filtration goes. Okay.